Hey guys, today is a day almost exclusively about algebra. In fact, we're going to do some definitions, and the first one is the word algebra. So we're going to talk about him, and you're going to get the main idea, what makes algebra algebra. You know what? It's going to be a lot of definitions. Let's have colorful definitions. So what is algebra? It is a foreign language. A lot of people say, I don't understand anything it says, because it's a foreign language. So it's a language. But it's not a language like we're used to a language, because it's a language of symbols. And those symbols can include numbers and operations. And not only does the language include symbols, it also includes including the keyword variables. That's what makes algebra algebra, are the variables. What are variables, Miss Rosner? I'm glad you asked me that question. I'm going to answer that right now. So I'm going to talk about a variable. And a variable is a symbol, usually a letter. Now I have seen sometimes in the algebra book they'll have these crazy problems where it doesn't look like an operation that you're familiar with, and you don't know what these symbols are. They'll use an asterisk, they'll use an and symbol, all sorts of weird things. But turns out that they're just holding the place of something. I'm giving away the definition. So it's a symbol, usually a letter, used to represent an unknown value. An unknown value. Its value changes in the context of each problem. Now, what do I mean by that? Okay, so Mr. Cuneo was my 8th grade algebra teacher, and he liked X, and so he trained me to use X. So anytime I do an unknown, I call him X, and I tell people what he represents in that problem. So in one problem, when I solved for that X, I got the number 12. And another problem that had X, I solved and I got 13. And another problem I solved that had X, and it equaled 5. So I'm thinking to myself, how can one variable X represent different values? Well, that's the beauty of a variable. It's just a holding place, basically. You're used to seeing a box when you were little. That box is what's missing, okay? And we're just going to use a letter instead of a box to hold the spot of the piece we don't know until we can solve it, okay? So remember we talked about in the notes, I think on exponents, we talked about a numerical expression. So today we get to add an algebraic expression. An algebraic expression. So let's highlight him. And let's go to pink. How about that? So it is a numerical expression numbers and operations. So an expression has to have some math happening in it, and a numerical one has numbers only, but to make it algebraic, we add variables, with variables included. Oops, forgot the word variables. There we go. And soon as you have any kind of mathematical expression So remember, no equal sign. That has a variable in it. It's now an algebraic expression. All right, well, fabulous. So x plus 5. What the heck does that equal? Well, that's when we learn another word you've heard before, evaluate. And evaluate means we're going to replace, it actually has a lot of meanings, but in our context, it's you're going to replace the variable with its value. And you're going to say, well, if it says x plus 3, how do I know what that equals? Well, they give you it. So I'm going to write here given. So they're going to tell you, evaluate x plus 3 when x equals 12. Okay? Then find the value of the expression. So we're going to boil down to a numerical answer. Okay, so evaluate means to get to an answer, get to a value. Okay, if you kind of look at those letters right there, they kind of spell out the word value. All right, I got one more for you, and that is substitution. Now, substitution happens all throughout math, tons and tons and tons. Let's see, let's add this guy. So it is the act of replacing a variable with its value. Okay, so when I say, hey, well, x equals 12, then I substitute 12 in for x in that little expression, and then I solve it, okay? Now, something that, again, I think we've talked about before, and I've certainly have used it and kind of spoken about it, is that we have new ways of showing multiplication. And when we have variables, it adds a few more. So ways to show multiplication. With variables. So this means I'm multiplying things with variables. I could be multiplying variables with variables. So I'm going to show 4 ways of doing this. Okay, so way 1. Actually, let me underline this. So way 1 would be 5 times x, okay? So we've got 5, and then that guy in the middle is times. So that dot is the one. And remember, we've talked about that, where we're getting to a point where that x, we're not exactly sure what he represents anymore because x is a variable. Though if you notice how I write my variable x, it's more kind of italic or curvy. So a different way to write it would be 5 and then parentheses and then x. And so when you see a number and it's butted right up to parentheses, that means times, and then we have the x. Okay. And then another way would be if I just have a variable that's butted up to, or a number that's butted up to a variable. So this is 5, and it's right here. You know, that's times. The reason why that's important is because a lot of times, like, you'll be told x equals 2, so kids will substitute in 2 for x, and they'll say, oh, it's 52. No, it's not. It's 5 times 2, okay? So 5 times x. And then one more way is to just get everything all in parentheses. So we'll have 5 in parentheses, and then butt it up to parentheses, and that's x. So this is us saying 5. And again, you don't see the symbol, but it's right in between. That's your times. So when parentheses touch parentheses, and then x. Okay? Now I'm going to go to the next screen. Now you should only be about halfway down the page, maybe 2/3. And so we're going to finish up for the bottom of the page. So I'm going to go to the next screen, and we're going to talk about the strategy to find the value of an expression. To find the value of, well, you know what? Let me change this. Let me add a word here. Algebraic expression. An algebraic expression. If it's an expression, we can just solve it, right? Use order of operations. And with algebraic ones, we can use order of operations once we substitute in values. Okay, so what we're going to have to start us off is a prep step. That means before I do any math. Prep step. So prep step 1 is to substitute that word we talked about earlier. Substitute the value for the variable, or the value given, for each variable. Now you may only have one variable, you may have more than one variable, so however many you have, substitute the number in. Okay? Then we're going to solve, and we're going to use what we talked about yesterday, the order of operations. And remember, you guys are used to hearing PEMDAS for please excuse my dear Aunt Sally, which is parentheses, exponents, multiplication, division, adding, subtracting. And we changed it to a G, so more like GEMDAS or GEMDAS. So we start with the G, and he is grouping symbols. And we talked about how there's way more than just parentheses. Symptoms, symbols, hello, symbols. There we go. And then we had E, and that was our friend exponents. And then we had M/D, so it's multiplication or division. So we're going to multiply or divide, whichever comes up first, as you read from left to right, like we read a book. And then last is addition or subtraction. So we're going to add or subtract, just like I said before, as we go from left to right. Okay, so now we're going to go to our next page with our examples, and we'll be done for the day. So let me get the title back in. So this is our second page now, 6-3, variables and expressions. So good old algebra. Okay, so our directions are going to say evaluate, each expression. Now we can only do that if they tell us the value for the variable. Oh, let me try that again. I forgot the word each. Too many E's, I guess. Each expression. A lot of alliteration, huh? So first one, we have A plus 8. Not Kate plus 8. 8. A plus 8. If A equals 6. So remember that word substitution? What substitution says is we're going to take that value 6 and substitute it into our algebraic expression in the place of A. So we would have 6 plus 8. Now, this is going to be your temptation. Add it up, you get 14. Your temptation is to not show any work. However, you got to show me that substitution step. Yes, sir. Or I'll get very, very, very not happy. We have 9c if c equals 1/3. Oh, yeah, sorry, friends. We're always going to be working with fractions and decimals. So we're going to take that 1/3 and substitute it in for c. And remember what we talked about earlier? When I see a number butted up to a variable, that means to multiply. So I get 9 times 1/3. So I can go ahead and give 9 a denominator of 1. I can divide out a 3 from the 3 and the 9. They're on a diagonal. And I multiply straight across. And I end up getting 3 over 1, or 3. Okay, next one. Ooh, more stuff. 5t plus 4. So see how I do my t's with the little tail? That keeps it from looking like a plus sign. If t equals 3. So again, I'm going to take the 3 and I'm going to substitute it in when I see t. Now we're going to be talking about later in the chapter that the role that the 5 plays when it's being multiplied by the variable, he's called a coefficient. So we'll talk about that later, but really important to understand, again, that's a multiplication problem. So we're going to have 5 times 3 and then plus 4. Okay, and then we follow order of operations. So no parentheses or any kind of grouping symbol, no exponents, but there is multiplication, so we'll start with that. And that gives us 15, and we write out the rest, plus 4, and then we add that together and we get 19. So again, you must resist the temptation to do work in your head. Not going to be impressed by that. 50 minus 3d. If d, sorry, I write 12 and I say d equals 12. So again, we're going to take the value that d equals and substitute it in. Then we write out the problem. So we're going to get 50 minus 3, and I'm going to show times with parentheses, just so you can see it a different. All right, d, dopey, 12. Okay, so now let's see, no grouping symbols, no exponents, but we do have multiplication. So we're going to start with the multiplication, and we get 3 times 12 is 36. And then we're going to subtract 50 and 36. So if you have trouble doing things in your head, just do it off to the side like this to prevent silly errors, and we get the answer is 14. Okay, so 2 steps on number 4, 2 steps on number 3. The other 2 are just 1-step equations. All right, let's see what our last one gives us. Oh, somebody we haven't seen. So we have 6s squared if s equals 1/2. Okay, so we're going to substitute in 1/2 in for the s. So first thing we have to remember is 6 butted up to the s. That 6 is that coefficient I was talking about. And then times, and then we're going to put in 1/2 for s. Actually, let's go ahead and use the parentheses that we would. And then we're going to square that guy. So remember what squaring is, and think about order of operations. We do have an exponent. We don't really have grouping symbol because it's just one thing in there, but we do have exponent. So remember what that's going to tell us to do. 1/2 squared is the same as 1/2 times 1/2, which is 1 times 1 over 2 times 2, and that gives me 1/4. So I get 6 times 1/4. Now I'm going to go ahead and give this guy a denominator, and then I'm going to simplify. They're both even, so I'm going to divide a 2 out, and I end up multiplying straight across. 3 times 1 over 1 times 2. And I can leave the answer just like that. Or if I wanted to change it to a mixed number, 2 goes into 3 once with 1 left over. So 1.5 could be the other answer. And that's it. All right, well, have fun with this, guys. We'll see you tomorrow. Bye.